Tonight, the solar system holds its breath. Above the red sands of Mars, a visitor from the stars is racing past at unimaginable speed. Its name is 3I Atlas, only the third interstellar object humanity has ever confirmed, and tonight it will skim by Mars at just under 1/5 of an astronomical unit. That distance sounds vast, about 28 million kilometers, but in cosmic terms, it is a brush with destiny. This is not just another comet. 3I Atlas carries a blazing emerald glow, a pulse of light that flares and fades as if beating with some hidden rhythm, and tiny accelerations that defy every model of outgassing we know. Earth's instruments for the next 6 hours will be blind. The geometry of the sun cuts off our view. Only the orbiters around Mars, MAVEN, Mars Express, ExoMars TGO, remain as our eyes and ears. The blackout is no glitch. It is the alignment of worlds. And in this brief window, everything we learn, or fail to learn, could change how we understand visitors from beyond our sun. Is this a bizarre comet shaped in the coldest reaches of interstellar space? Or could it be something engineered, something that rewrites the definition of alien? As the countdown ticks towards zero, the red planet becomes the stage for a mystery that could define an era. Tonight, Mars alone will decide what secrets 3I Atlas reveals to us, and whether those secrets confirm the power of natural science or open the door to the extraordinary. The story of 3I Atlas begins far from tonight's spectacle. It first revealed itself not through a grand observatory, but through careful eyes watching faint points of light shift against the stars. At first, it looked like another icy wanderer, a comet drifting in from the edge of the solar system. But its speed and its trajectory told a different story. This object was not bound to our sun. It had come from the deep between the stars, and like Oumuamua and Borisov before it, it would never return. From the very beginning, Atlas refused to behave like the others. Its coma glowed a vivid emerald green, a hue that persisted across multiple instruments, peaking around 516 nanometers, an intensity unmatched by any solar system comet. Amateur astronomers were among the first to notice its light curve pulsing with a steady rhythm, brightening and dimming as if some hidden metronome was at work. Professional telescopes confirmed the mystery. The pulses were too regular, too clean, to be explained by random jets of gas. Even stranger, those light pulses matched subtle nudges in its motion. Tiny accelerations, almost like course corrections, coincided with each brightening event. Physics offered no simple answer. Typical outgassing should be jittery, uneven, leaving the comet tumbling off balance. Instead, Atlas seemed almost deliberate. Then came the chemistry. Spectroscopic studies showed carbon dioxide dominating its emissions, with a carbon dioxide to water ratio more than 8-to-1. That ratio is an order of magnitude beyond the richest volatile comets we know. Dust analysis suggested grains larger and slower than expected, drifting in broad, lazy arcs instead of chaotic jets. Piece by piece, the dossier grew stranger. Unlike Borisov, which roared through the solar system with all the hallmarks of a natural comet, or Oumuamua, which reflected light in odd ways but left no gas behind, Atlas combines both mysteries, the chemistry of a comet with the motion of something that does not quite obey the rules. From the moment it entered our system, astronomers knew this would not be just another flyby. It would be a test of everything we thought we understood about interstellar visitors. For most cosmic events, Earth's vast network of observatories and telescopes would stand ready. From the mountains of Hawaii to the deserts of Chile, from orbital satellites to deep space antennas, our planet usually holds the advantage of constant coverage. But tonight, for the next 6 hours, Earth is blind. This blackout is not a failure of technology. It is geometry. As Atlas skims past Mars, the sun slides directly between Earth and the object. The glare washes out every telescope, every spectrograph, every eye we have. The only vantage point left belongs to Mars, the planet that now sits at just the right angle to see what we cannot. For that reason, every spacecraft orbiting Mars has been thrust into emergency duty. MAVEN, the veteran spacecraft studying the Martian atmosphere, is now running its ultraviolet spectrographs at maximum cadence, ready to catch faint emissions in the comet's tail. Mars Express, the European orbiter, has shifted its spy camera spectrometer into continuous imaging mode, stacking exposure after exposure to capture even the faintest trace of fragmentation. And the ExoMars Trace Gas Orbiter, with its powerful NOMAD and ACS spectrometers, scans the coma for gases that do not belong, searching for chemical fingerprints outside the solar system norm. On the Martian surface, even the rovers Perseverance and Zhurong have joined the effort. Though their instruments are less sensitive, they can still detect subtle changes in the thin atmosphere, shifts in dust patterns, ionization ripples, or even strange auroral glows at the horizon. Every data packet matters when Earth is silent. This is what makes tonight extraordinary. It is not only that Atlas is closer to Mars than any interstellar object has ever come. It is that the red planet, for a brief span, becomes the solar system's only observatory. Mars has become our eyes, our ears, our nerve center. Every orbiting probe is stretched to the limit, its power and memory budgets pushed to exhaustion. Every moment of data must be captured, because once the blackout lifts, the chance will be gone. For 6 hours, the fate of Discovery rests on a handful of machines circling a distant world. Their teams on Earth rehearse each step, preparing to pivot in seconds if Atlas flares, fragments, or shifts course. The window is razor thin, the pressure immense. And as the comet draws closer, so too does the sense that something extraordinary may be about to happen. In a quiet building thousands of miles from Mars, the air is thick with tension. Inside the Maven Control Center, the so-called Red Watch team takes their positions. These are the operators trained for contingency, the crew drilled in rapid decision ladders for every possible anomaly. While the rest of the solar system goes blind, they are the front line. Clocks line the wall, each synchronized to the second, counting down to the blackout window. At one console, a technician rehearses switching from standard science mode to burst mode spectroscopy in less than 2 heartbeats. At another, engineers run final cross-checks with Mars Express and the Trace Gas Orbiter, confirming that every relay window is locked, every data pipeline secure, nothing is left to chance. Backup configurations are already loaded into memory. Redundancy rules everything. Each packet of data will be duplicated, logged, and stamped with an independent checksum before it leaves Mars orbit. The Red Watch knows there is no room for a single point of failure. Their playbook reads like a thriller. If Atlas flares unexpectedly, Mars Express must capture broadband images in a rapid burst, stacking exposures to freeze the event. If the coma shows signs of fragmentation, TGO spectrometers will shift instantly to high-priority trace gas mode. Maven's particle sensors and magnetometers are tasked with watching for ripples in the Martian ionosphere, tiny twists in the magnetic field, or sudden spikes of charged particles that could betray an unnatural interaction. The abort threshold is written in red ink, a 30% increase in particle density above the last measured spike. Cross that line, and instruments may be forced into safe mode to protect the spacecraft. Lose one orbiter, and the chain of evidence collapses. Every operator is on edge. They sip cold coffee, eyes locked on streams of numbers and graphs, each keystroke carrying the weight of discovery. One wrong delay, one overlooked anomaly, could erase history. Yet there is no panic here, only precision. Every command is read aloud, confirmed by a second voice, and logged by a third. This choreography of caution ensures that when the extraordinary happens, nothing is missed. Beyond the walls of the control room, amateur arrays in backyards from India to Arizona are listening too, their modest telescopes feeding data into global databases. But it is the Red Watch that carries the burden. For 6 hours, the hopes of unraveling one of the strangest interstellar objects ever seen rest on their shoulders. And as the minutes tick away, the question lingers like static in the air. Will tonight bring another cometary oddity, or the first undeniable hint of something engineered? The strangeness of 3i Atlas is not built on a single anomaly. It is the accumulation of oddities, stacked one on top of the other, that paints a portrait so unusual that even the most cautious scientists admit this is not like anything we have seen before. First comes the glow. Most comets shine in familiar tones of white, blue, or faint green caused by the breakdown of cyanogen or diatomic carbon. But Atlas glows with a vivid emerald, its peak at 516 nanometers, confirmed across multiple instruments. Ground-based spectrographs in Hawaii and Chile, orbital spectrometers from Earth, And now the fleet at Mars all agree. The color is too intense, too stable, to fit the standard comet playbook. The usual suspects, C2 swan bands, carbon monoxide emissions, cannot explain the brightness. Instead, nickel emission lines, usually faint, blaze more brightly than iron by factors of 4 or more. It is a reversal of chemistry that breaks the template. Then comes the chemistry of the coma itself. Spectroscopy reveals a carbon dioxide to water ratio greater than 8:1. That is not just unusual, it is unprecedented. Even the richest volatile comets in the Oort cloud carry far more water than this. In Atlas, water seems almost absent, replaced by frozen stores of carbon dioxide and possibly even stranger ices formed in the coldest regions between the stars. Laboratory models struggle to match the balance. Some suggest Atlas was born in a place so far from a parent star that water never condensed in abundance. Others whisper that such chemistry might not be natural at all. The next anomaly is motion. Comets usually outgaze in chaotic spurts, releasing jets that tumble the nucleus, sending it spinning unpredictably. But Atlas moves differently. Astrometric tracking has revealed micro-accelerations, tiny nudges that appear synchronized with its pulses of light. Each flare of brightness coincides with a subtle course correction. They are too precise to be random, too rhythmic to be explained away by uneven heating. To some, it looks almost as if an invisible hand were applying measured thrust. Dust adds yet another layer to the puzzle. The tail of Atlas does not behave like ordinary comet dust, which streaks away in fine jets. Instead, its grains are larger, slower, drifting in broad, lazy arcs that resist easy modeling. Polarimetry shows a deep negative polarization branch, a property more often seen in asteroids than in icy wanderers. To observers, the dust looks less like a chaotic spray and more like material being released in carefully measured bursts. And then there is the rhythm. Citizen astronomers like Priya Raalo in Pune first noticed it. The repeating pulse in the light curve, brightening and fading with clockwork regularity. Professional arrays confirmed it. The spacing between pulses is nearly identical, the rise and fall too clean to be random. Even as Atlas approached the sun and solar glare threatened to blur, the signal, the rhythm held, unbroken, as if switched on and off by design. No single anomaly is enough to rewrite textbooks, but together they defy simple categorization, a comet that glows emerald with unmatched intensity. Chemistry dominated by carbon dioxide far beyond expectation. Dust grains that move like lazy embers instead of wild sparks. Pulses of light paired with subtle accelerations, repeating like a heartbeat in the void. Some scientists argue these are just outliers, rare but natural quirks in an object forged in the harshest corners of space. Others insist the evidence points to something more. Tonight, as Atlas brushes past Mars and Earth sits blind, every instrument is focused on these anomalies, searching for one more clue. Because if even a fraction of these signs hint at something engineered, then 3i Atlas is not just a visitor, it is a messenger, and that possibility changes everything. For every extraordinary claim, the scientific community insists on exhausting natural explanations first. And with 3i Atlas, several models have been proposed, each one stretching the limits of what we know, but none entirely impossible. The first explanation looks to chemistry shaped in the coldest corners of interstellar space. Imagine a place so far from any star that water ice is scarce, where carbon dioxide, carbon monoxide, and rarer ices dominate. In such a cradle, a body like Atlas could form with an extreme ratio of carbon dioxide to water, more than 8:1. This would explain the rare chemistry without invoking anything artificial. We already know of comets with high carbon monoxide content. Atlas could simply be a more extreme version, a frozen relic from an unimaginably distant nursery. Another model turns to structure. Deep beneath the surface of Atlas, volatile pockets may lie buried like hidden mines of gas. As sunlight seeps through cracks, it heats these reservoirs until they rupture. If the pockets are distributed unevenly, they could produce rhythmic bursts of outgassing. Laboratory simulations suggest that layered ices can indeed trigger repeated pulses if they warm and cool in cycles. In this scenario, Atlas is not a mystery machine. It is a fragile relic, its strange heartbeat driven by ancient fractures and trapped chemistry. Dust dynamics offer a third pathway, The emerald glow and unusual polarization may be linked not to the nucleus itself, but to the composition of the dust. Larger, carbon-rich grains could scatter light in ways that mimic engineered pulses. Their heavy mass would explain the broad, lazy arcs of the tail. The sun's radiation and the weak magnetic field of Mars may shape these grains into unexpected trajectories. Seen from a distance, the dust could appear to pulse, even though the nucleus itself behaves normally. A fourth possibility admits the limits of our models. Only 2 other interstellar visitors have ever been recorded. With such a tiny sample, it is almost guaranteed that new arrivals will fall outside our predictions. Microaccelerations, synchronized light curves, and odd spectral lines may simply reflect physics not yet captured in our equations. Interstellar objects travel at extreme velocities, spinning, tumbling, and shedding mass in ways we have not fully mapped. Atlas could be reminding us that our textbook rules are too narrow, that the universe has more tricks than our software can model. Each of these explanations is grounded in natural science. None require alien engineering, and yet each leaves gaps. The extreme carbon dioxide ratio is rare, but not impossible. The pulses could be coincidence. The dust could be unusual, but still natural. Piece by piece, the models bend under the weight of anomalies, but do not entirely break. This is the careful balance of planetary science. Until every natural pathway is tested, until every model is run to exhaustion, the extraordinary remains only speculation. For some, this is frustrating. Why not admit the possibility of design? But for others, it is discipline. Science advances not by chasing the exotic, but by ruling out the ordinary. And so, tonight, as Atlas races past Mars, every anomaly recorded will be pushed through the gauntlet of natural explanations. If the chemistry can be explained, if the pulses can be modeled, if the dust can be understood, then Atlas will remain a comet, bizarre but natural. Only if the data survives every natural test will the door to the extraordinary even be considered. Beyond the guarded corridors of science, another idea has taken hold. What if 3I Atlas is not a comet at all? What if its strange chemistry, its rhythmic pulses, and its subtle course corrections are not natural quirks, but signs of engineering? It is an unsettling possibility. To some, the emerald glow looks too stable, the pulses too precise, the micro-accelerations too deliberate. Each flare of light followed by a nudge in trajectory feels less like random outgassing and more like a maneuver, tiny thrusters firing in sync. If so, Atlas could be more than a drifting rock. It could be a probe, a messenger, or even a relic from a civilization beyond our sun. But the scientific community is cautious, almost to a fault. Extraordinary claims demand extraordinary evidence, and so researchers have created strict rules. No single anomaly, no matter how strange, is enough. Only converging evidence from multiple independent instruments can raise the possibility of engineering. A pulse of light by itself proves nothing, but a pulse confirmed by 3 spacecraft, paired with a simultaneous course change, and accompanied by spectral lines that defy every known chemical model. That is where the conversation begins. The framework is called the decision matrix. For Atlas, it lays out 3 possible verdicts: conservative, hazardous, and extraordinary. The extraordinary path requires not one anomaly, but at least 2, confirmed by separate teams with statistically significant data. It is a high bar designed to prevent premature leaps into speculation. Still, whispers persist. Engineers point out that the tail of Atlas seems to release dust in measured bursts, not chaotic sprays. Astronomers note the repeating pulse is unblurred even as the object approached the sun, as if powered by something steady. And skeptics of the natural models argue that no comet has ever combined all of these oddities in one package. Perhaps it is not a coincidence. If Atlas is engineered, the implications are staggering. It would mean humanity has witnessed not just another visitor, but evidence of intelligence beyond Earth. Was it sent intentionally, or is it debris from a civilization long gone? Is it observing us, or merely passing through? These are questions too large for any 6-hour window to answer. For now, the extraordinary remains a hypothesis. But the fact that it is even on the table, that serious scientists are debating whether Atlas could be something built, shows how far this interstellar visitor has pushed the boundaries of what we thought possible. As the final minutes of the blackout window unfold, the truth of 3i Atlas remains suspended in data streams racing from Mars back to Earth. Operators watch their screens, amateurs refresh their feeds, and scientists around the world wait for a verdict that could fall in any of three directions: conservative, hazardous, or extraordinary. But even before the verdict is declared, Atlas has already changed us. It has forced a new level of transparency, accelerated protocols that demand open archives, and united professionals with citizen scientists under a single mission: to witness the unknown together. For the first time, a cosmic visitor has not been studied by a handful of institutions behind closed doors, but by an entire planet working in unison. And perhaps that is the deeper meaning of tonight. Whether Atlas is a bizarre comet born in the darkest corners of space, or something far stranger, its legacy is not just in the anomalies it carries, but in the way humanity has responded. We are no longer passive observers of the cosmos. We are an interconnected network, stretching from backyard telescopes to billion-dollar orbiters, pooling our vision into a single, global eye. Mars has been our sentinel tonight, the lone outpost with a clear line of sight. For 6 hours, it became the beating heart of planetary science. And when the blackout lifts, when Earth's instruments regain their view, the data gathered in that span will ripple across history. It may confirm that nature still holds the final word, or it may whisper that we are not alone. As you look up at the night sky, remember, a piece of interstellar space is passing by our neighbor at this very moment, leaving questions we may spend decades answering. The red planet is watching on our behalf, and through it, so are we. Whatever Atlas truly is, one truth is already clear. Tonight has shown us how small we are, how vast the unknown remains, and how powerful we can be when we face it together.